Hey everyone, Nitesh this side. Hope you're doing well. So let's start with the question. So the question is game of life. So according to the this Wikipedia article, so the game of life is also known as simply as life is a cellular automated division by a British mathematician John Horton Conway 1970. Okay. So you are given a board is made up of M cross N grid cell where each cell has an initial state, live or dead, basically live basically represented by a 1 and dead basically represented by a 0, and each cell interact with its 8 neighborhood, basically if you can say horizontally, vertically and diagonally. So there are 8 neighborhoods to each cell. So there is one cell if you can say, so it can go in 8 direct. They have 8 neighbors. So 1 2 3 4 5 6 7 8. Okay. So there are some operation that you can perform. So what you have to do, you have given one state array and you have to calculate the next state is creating by the above rules. So these are some rules that you have to perform and you have to give the new state. Okay. So let's understand with an example. Okay. So let's take this example. So basically 0 represent dead and 1 represent live. Okay. So first of all, let's understand these rules. So what it is saying, like any live cell with fewer than 2 live neighbor dies as if caused by underpopulation. Okay. So it will be like if, yeah, let's give a cell is equal to 1. Basically, it's a live cell. Then what you have to do, you have to check basically if it have the fewer than 2 live neighbors. Okay. So if it is having the cell basically lesser than 2, basically you can say the live, let's write it. So if your cell is basically 1, you can say, and if your live is lesser than 2, then your cell will become basically dead, so it will come into zeroth state. Okay. Else the second condition is if the live cell with 2 or 3 live neighbor lives, it basically live on the next generation. So if you can say if your live equal to 2 or live is equal to 3, your cell will become remain as it is, so it will remain as 1. Okay, so it's a else if condition. So let's write it down like this. And there will be one more condition if live cell with more than 3 live neighbor dies. Okay, so else if your live is greater than 3, then your cell again die, so it will become 0. Okay, let's check for the final condition. So if any dead cell with exactly 3 live neighbor become a live cell. Okay, so else you can say basically if live equal to 3, then your cell will become again to a new state. Okay, so this is for cell equal to 0. Okay, so these are some 4 conditions. So I think we can arrange them in a proper manner. So this will be like you can say if cell is equal to 1, then we do something, else we do something. Okay, so else part is pretty clear. If your life is equal to 3, then cell is also 1. And let's write this 3 condition into one condition. So it will be like if your life is less than 2, or life is greater than 3, then your cell will die. Other than that, it will remain as it is to a same state. Okay, so we have converted this condition into this. So let's try this condition onto an example. Okay, so now let's apply these conditions to this example. Okay, so we have this 2D matrix 0 1 2 0 1 2 3. Okay, so we will start from here. Okay, what we will do, we will calculate its all neighbors 0 and 1. So we will count 0 and 1 for each element. Okay, basically it's neighbor. So we will go in all the, so let's say you are at this position, so you will go this direction, this, this, and this. Okay, so 8 direction you will count. Okay, so for this you will calculate the 0th one. So you can see for this you have 1 0, second 0, and there are no in the left part, and for 1 it is only having 1 1. So this is having you can say 0 equal to 2 and 1 equal to 1. So now we have count the 0 and 1. Now we'll go to this condition. Okay, so you can see our current cell is 0. Okay, so this lies in this condition. Now we check if live equal to 3, live basically the 1. Okay, so 1 is live and 0 is dead. So if live equal to 3, so as you can see 1 is equal to 1, so this is not equal to 3, so this will remain as it is, so this is 0. Okay, now we'll check for this. So we'll count its all the neighbors. So for this we can say 0 equal to 1 2 3 4 and 1 equal to 1. Okay, now what we can see is okay, so what we can see, this lies in this condition. Okay, our current cell is 1, and after this we'll check if live is less than 2 or live is greater than. So as you can see, this is less than 2, so we'll make this as a 0. Okay, so this is the 0. Similarly, you come at here, you again calculate the 0th and 1. So for this case 0 is uh, 1 and 1 equal to 2. Okay, now this lies in this condition. Okay, now we check if live equal to 3. So no, this is not equal to 3, so will remain as it is. Okay, we again do for this. So let's calculate the 0th and 1. So for this 0 is, you can say 1 2, and 1 is 1 2 3, basically this and this, so this is 3. Okay, now we'll check whether this lies in this condition. So as you can see, our current element, our current cell is 0, so we lie in this condition. And if live equal to 3, yes, as in this case 0 equal to 3, so we will make this as a 1. Okay, so similarly we have to do this for all the element, and we can create a new state. Okay, now you can create a new separate array and 2D array, and you can fill all the element in it, but in the question it's saying you do it in place. Basically you don't have to create a new array, you have to just update in the same array. Okay, so what we will do, like every time whenever we update, so as you can see we become this we created this 1 as 0 and this 0 as 1. So what we will do, we will take the same array, and like at this position if we make this as 0, so if you make this as 0 at this position, if you count the 1, it will say like only 2 1 are there, but in reality there are 3 1. Okay, so how can you make this compatible? So what we will do, for every updation we will basically do, whenever we update a 0 or a dead element, we will replace it by 2. Basically this will also representing a dead element, but this is changed from 1 to 2, it become 2. Okay, so as you can see this is the new element, so we will make this as 2. Okay, now whenever you encounter a 1 and you have to basically, so this will represent a live element, and this will come from, this 3 will come from 0. Basically as you can see this is 0 and you make this as a 3. Okay, so when you count for this position, so when you count for this, what we will do, we will count again the 0th and 1. So as you can see for this position, zeros are 1 2 2, and this is also 1 0. So how can we identify? So we will identify whether is this 3, so we will count it as a 0. Okay, so it will be clear if we write the code. So this 2 and 3 I take because in a question it's saying you have to do in place. Okay, so let's write the code. Okay, and before writing the code, I need to discuss one more thing. How basically how can we go in the 8 direction? So what strategy I follow is I just created a graph like this. So this will be my initial state, and for every updation, so I will basically do this will become 1 0. Okay, you have increases your row, then if you have to decrease your, so this will become minus 1 0. And if you have to increase your column, so in the right direction, so this will be 0 1. Okay, and if you have to decrease, so this will be 0 1. So this is for only 4 direction. Let's create for 8 direction. So this will now become minus 1 1. This will become 1 1. Okay, and this will be, you can say, 1 comma minus 1, and this will be minus 1 minus 1. Okay, so I can take any, so I will take two array, x array, and I will take similarly a y array. I can start from any position, and I can just take this starting element, so 0, then I will take the starting 1, then 1, then will be also 1, then 0, then minus 1 minus 1 minus 1. Okay, this is for x direction. Similarly, I will take for y. So this is 1 1 0, minus 1 minus 1 minus 1, 0, and after this one. Okay, you can take it any direction, and you can learn this, but I generally draw it and then create my neighborhood direction. So let's write the code for this. Okay, so let's write the code. So I have again like taken this x and y, so I just explained this. So now let's write the main logic. So let's take this row and column in a variable. Okay, then we iterate over our board, basically ni plus plus for nj 0 to mj plus plus. Okay, now what we have to do, we have to go in 8 direction and count zeros and ones. So let's take variable 0 equal to 0 and 1 equal to 0, and we'll go in 8 direction. So let's take a new loop, k less than 8, k plus plus, and what we will do, we will calculate our new row, basically new I, and we will calculate our new j. Okay, so new I will be I plus x of k, and your new j will be j plus y of k. Okay, so you have calculated your new I and new j, but there should be some safe condition or some base condition, because let's say if I am at this position and I can calculate the new I at this index and this index, so I need to handle the edge cases also. So what we will check, if new I is greater or equal to 0 and new I is less than n. Similarly, new j is greater than 0 and nj is less than m. That means I am in the safer condition. I can go and check if my new element, both new I, new j, is equal to 1. So I will increase my 1 counter, otherwise I will increase my 0. Okay, so after this loop, basically, I have counted 0 then 1. So let's close this. So we have done with this. Now we need to add our condition. So what's our condition? If your current element, basically your current element is 1, you will do something. Else, if it is 0, that means it did, you will do something. Okay, let's write the else condition first. So what is the condition in the else? If the live condition, basically the 1 equal to 3, then you basically down your, so what we will do, we will dead our current element, both I j equal to 2, and it will be, so we have make this like in the new state it should give us the 1, but currently we are giving it as a 2. Finally we will, like in the last, we will convert every 2 to ones and every 3 basically uh, to 0. Okay, so if in this condition, if 1 is less than 2, or 1 is greater than 3, we will make it uh, you can say 3. Okay, So we have, I guess, done with the main logic. Okay, there is one more condition in this. Uh, there might be a chance like your current one is become dead state. Okay, so what we will do, if board of new I, new j, it become dead, but in the earlier, like we need the previous state, so that's why we have taken a 3 variable. So we will increase our one. After this whole logic, what we will do, we will make every 3 to 0 and every 2 to 1. Okay, I plus plus and okay, I plus plus 4 int j0 jm j plus plus. What we will do, if your board of I comma j is equal to 2, we'll do something, else if board of I comma j is equal to 3, then we'll do something. Okay, so if it is 2, what we will do, we will basically, it is in the dead, it coming like it's, you can say at this point condition, this is earlier in the dead state, then you make it a live state and you make it as 2. Okay, so we convert this into 1, and the opposite for live state, I j, this will become 0. Okay, I hope this logic is clear to you, why we have converted 2 to 1 and 3 to 0. If you have any doubt, you can ask in the comments. So let's run. Let's see. Okay, so there is one error. If new I is greater or equal to 0, new I less than n, new j is greater or equal to 0. The condition looks good to me. New I, new j, similarly new I, new j. Okay, oh, there is one mistake we have done. So this is for, like, if you can see, the rows are 1 2 3 4, but columns are 1 2 3. So we are doing it board.length, so that will give us 4 in both the index n and m. So let's run it now. So this is accepted. Let's submit it. So our code is submitted. The time complexity is this, it's basically we are using 2 loops and it's n into m, and inside that we are doing one more loop for 8 times, so it's n into m into 8. Like 8 is a constant, so you can neglect that, so it's on an average it's n cross m. Space, we are not using any other extra new array, so it's a order of 1 time complexity for that. Yeah, hope you like it. Thank you for watching my video, and do join the Telegram group if you're in doubt and any concern. Thank you.